So you can use it as something to give a name as an alias. And for instance, you can also group columns, so you can say all of this table as, and then the table name, and then in the result row you have a member which has the name of the table, and that again has then the columns as members. So you can have, you can use this for grouping, for instance, of result columns. So it's just there for convenience, that you have this thing available and you don't have to define the table name on your own if you want to use this for an alias, for instance. Otherwise it wouldn't be needed. Okay. And the table class that we saw on the previous slide inherits from a template. This one here, and we skip all the details, but what's important is this inheritance here. So we have column specifications like the ID thing that we saw a few slides back. And we use those specifications to create column classes, which then really have some functionality, like operators and functions, like a like function, or you can concatenate them if there are strings, stuff like that. So that is all handled by a column template, and the column template uses these specifications to know what type it is, and later on what name it is. And we want to bring this table into the this column into the table with the right name. Should be a member, because that's what we're using all the time in the statements before. And we do this by the member template, which is part of the column specification. Right? So you have the column specification, including this name thing, and that includes the member template. And the member template says, okay, I have a member of this type with a name ID. So with the first parameter, template parameter after the table itself is the ID column, then the first inheritance gives you a member called ID with a correct type, which is this column. And since the specification, including the member type here, is part of the column, or is known to the column, you can then later on forward this to other places in your template expressions, and then also construct result rows from that. Everyone's flabbergasted. Okay, does that make sense, or is this completely out of this world?
Don't you have an infinite recursion here?
I'm sorry?
Won't you have infinite recursion?
Yeah. You mean
because you
of the table?
template on table and column specs, but you unpack this argument pack. Oh, I don't know. I have
Okay. If you haven't ever seen very early templates, then we have to. I can't give you a crash course. But how to read this is, okay, we have a varied number of these arguments. Could be 0, and in that case you would get an error because you can't have an empty table. So it could be 1 or more. And you can use this in the normal way, like here, and the 3 dots at the end say, okay, do this thing here for all these arguments. Okay, so if we have ID, name, and quirk here, then this part, this inheritance, is done for these three. And this table thing here is not part of the variadic arguments, so we just hand it through to the others.
So this means table T is derived from member T, from this meta class.
Mm-hmm. Yeah. So it's one of the very, very few examples of multiple inheritance that I personally use. I think it's the only one, actually.
But it is right. Can you say table is a member? But usually when you derive, you say, yeah.
Oh yes, yes you can. I mean, if you really want to do that, that's yeah. You can cast table to this thing
Yes, of course, but
if you want to.
Would you want to decide?
Yeah. I didn't need to until now. Okay, so if you have concrete questions right now, so then let's talk about those. Otherwise, I suggest you let it sink in, because sometimes it takes a little bit. I know that. Wasn't too easy to develop it either. Yeah.
So, but a table will publicly inherit from member T of every single one of its columns.
Yeah.
Is that okay?
Yeah.
And then, can you maybe explain a little more what this name T, member T, column T magic does for you? So
well,
you're not.
Okay. So this until here, we're just
That's just the class.
specifying which template we're
Mhm.
trying to inherit from.
Maybe you can show the declaration of the
Yeah. Okay.
before. Yeah, exactly.
One.
this one.
No,
No, this. Yeah. Okay.
Yeah. Okay.
Yeah, this.
Anyway, so
This is
So we have a-
Name T.
it's pretty much the same for tables and for columns. So you have a name T, which contains everything about names, including this member template. And the member template
If you go
is
one slide before, you see the operators.
yeah, and the member template is specific for each column and table. So if you have a column called ID, then the member is ID.
And the reason you need the name T is just to have this get name function in there, or
Yeah, mostly, and even though there are these template aliases, in some situations it's just easier to hand types around and not templates.
Where do I get this name which you use
Yeah.
in your p dot name? How do I get the name attribute?
I'm sorry?
How do you get the name attribute in your select from p from p dot blah 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 dot
Yeah.
name?
You're inheriting from member T, so you cannot access the get name function, right?
yeah, but if you're writing
So,
a
sorry,
Publish.
please ask a
ID
question
is a
again.
column, right?
ID is a column, yes.
So you have columns like name, ID, whatever,
Yes,
and you select p dot name.
yeah.
How do I get this name attribute?
The name attribute
The
gets,
member.
if this were the name column,
Okay, I will get T name, right?
yes, right. Because this thing here, the name here, is specific to the column name. Okay, so it's ID for this one, it's name if this were the name column, it's cheesecake if this was the cheesecake column, And with this multiple inheritance, you can pull all these names for members with the correct type into your struct.
So, grossly simplifying, you're inheriting from all these member structs, which happen to have the right fields with the right types and the names. And
Yeah,
then there's
right.
a lot of, like, the outer two structs are kind of there to do the template magic. And some other.
Yeah, well, you have to have some.
Yeah,
or
yeah,
it's-
yeah,
it's
yeah. I
nice-
understand.
It's nice to have a container for all this stuff, because otherwise, you could use namespaces as
Mhm.
well, probably, but it's.
Yeah, but
horrible.
just to understand the definition on the next door, or the slide after
Mhm.
that. So that's basically what is going on a simplified level.
Yeah.
What do you do if you have a table with a field called, let's say, volatile or for or y? Or
Well, it doesn't matter,
okay.
because you're free to name this in any way you want.
Yeah.
So if you have a column called volatile, then you can put the name volatile in here, no problem there. You could even call this volatile with a capital V if you want. I mean, these names are free. You can do whatever you want here. And here you say, I don't know, volatile underscore or something like that.
Because I saw you name all the name, for example, get name, it has an underscore, probably because of also the same reason that you don't have name clashes or
Yes.
something. So, okay.
Yeah. So yeah, most of the internal stuff is currently prefixed with an underscore, so that you, assuming that you have table and column names that don't start with an underscore, and that you don't have name clashes there.
So, actually, is get name a private mem or is internal? It's internal function, because it could be quite useful. Also,
Well, currently I don't really see a real use for a user for this thing.
Okay.
Of course, it's required for anybody who wants to do something with this expression tree. So for the connector library that interacts with the database, these functions are very important, of course. So that it can serialize an object of a column into the appropriate string. Okay. Okay, then we've been there. So during the last meetup, and this is kind of related to names and types, I think Franz said something like, okay, name parameters, that's the one thing I'm really missing in C++, because Python and other languages that I use have name parameters. And it turns out that in sql+11 we have something which is pretty much named parameters. So yeah, in an insert statement, you say, okay, I insert into this column Q here, and I insert the column name with this, and whether it's fatal or not, with another value. And this looks like almost like name parameters, right? Maybe the Q dot is a bit weird, but we can get rid of that. Okay, so how can we do that? Or go back one slide. This expression here, what is that?
initialization.
Sorry?
An initialization, maybe. No.
Okay. Actually, it's not. So this thing here is a const expression. And so what this does here is it overloads the assignment operator to return something completely different. So you get a syntax which looks pretty much like SQL, I mean, within certain limits. And well, if you use this for some time, it feels quite natural. You don't even think that this might be an assignment because it's part of your SQL expression. But it does not do anything like an assignment. Okay. And what it really does is, maybe even next slide, it returns an object which contains the left-hand side and the right-hand side operands. And for instance, you could say, okay, I have a function that takes first name and last name, and the users of my library always confuse the order because in some places they are used to first go with the first name, then the last name, and others vice versa. I want to get rid of this problem. I want to use name parameters. Then you could do something like this. You create a struct with some name, and it's pretty much empty with the exception of the assignment operator. And let's say you have a string argument, then the assignment operator returns not an initialized version of this object, it returns an assignment, this thing here. And the assignment contains itself, which is the left-hand side operand, and the argument, which is the right-hand side operand. And then you just instantiate one of these, and then you have something that can be used as a name parameter. So you, if somebody calls your function, they would say first name equals and then a string, last name equals and a string, or they could exchange that. And the only thing that you have to take care of is to handle these arguments, of course, because you have to interpret what they are giving you and make sure that that they don't give you a first name twice maybe, or give you a middle name where you don't expect it, or something like that. Okay, and we're getting to how you actually can use these in your programs. Okay. Right. So in the insert statement that we just saw, this is rather simple. We take this is the constructor, and this set method creates an insert list and takes all the assignments that you have in your argument list and splits them up into a tuple of the left-hand side arguments, which are all the columns, and the right-hand side arguments, which are all the values, so that it can later be serialized into insert into table name, and then the column names, and afterwards the values. And there are many other ways of how you could use or interpret named arguments. I don't intend to go into that, but I have some backup slides. So if you're interested, I can show you some additional things. The important part is that you check whether the arguments are correct, of course, because as in all functions, you could make many mistakes here as a user of this library and put all kinds of nonsense in there in spite of the cool ideas of the developer of this library. Okay, does this make sense? Okay, no protests, that's good. Alright, so the next few slides are about how do we check arguments, because I mean, if we take these argument lists, typically with name parameters, we don't expect the user to give us all parameters, maybe only a few of them. The order could be completely garbled to what we expect normally. So we would have to check whether the arguments are correct and then evaluate them in the correct way. And the types of, or the classes of checks that are used in this library can be seen from pretty much any expression. We have things like all arguments must meet certain requirements. Like in this select call, all arguments here have to be columns or other named expressions. So they have to have the value and or some value type. They have to have a name. But they could be anything like columns. They could be expressions built out of columns. They could be subselects, whatever. But they have to be named expressions. It's also required that the names of these expressions are unique, because we cannot have multiple names of multiple columns of the same name, because that would give name clashes. So okay, uniqueness. Then all these columns, or all the columns in the select have to use tables that are elements of the set of tables that we have in the from. So we have some is-element of relation here. Then again, we have uniqueness for names of the tables in the from. All the tables, all the arguments here have to be tables, of course, or something that can be interpreted as a table, like a subselect, and same stuff with a where. So in total, we have everything I said already. So and these checks have to be done at compile time, of course, because that's the whole beauty of the library, that it gives you immediate feedback. It doesn't make sense to check them at runtime. And since we just took a look at what kind of checks we had, so it's all arguments must meet certain requirements. Types must be unique, and types have to be elements of a set of types. And I'm going to take a shortcut here because I think the time for this talk is not sufficient to really go into the details here of how to do that. But I wanted to make you aware of these kinds of type checks that you would like to perform if you're using things like named arguments, or in general variadic template arguments. These are typical examples, I would say, of things that you would like, of checks that you would like to perform on your arguments. So if you ever come across things like typesets, that sounds horribly abstract, but it's also wonderfully useful. And there are lots of typeset implementations. There's also a typeset implementation in this library. This could be a topic for a future talk if there is enough interest. But for the moment, I would like to leave it at that. That if you want to use things like what you have seen before, using type checks with sets is a very powerful tool. Okay. All right, and these are examples of what is done in the insert list. So we have static inserts for all kinds of type checks. In this case, we check if the number of assignments is at least 1. Then we check if we have duplicates in the assignments. or in the assignment types, that is. We check that with a periodic end, that all assignments are, the name indicates that they should be assignments, but we have to check if they're really assignments, so there is an assignment, is assignment trait to check that. And here's one semantic check. So as I said earlier, you could define in your column definition that a column is read-only, and then you can check that that none of these assignments is using a column which is read-only. And there are a few more, but the slide doesn't have more room.
So
Yeah.
this or t and this and t check the predicate on the list of types.
Right.
Okay.
Yeah. So yeah, this is a predicate, and this is the list of template arguments that you have. And just as you said, it's a combined end for all these conditions here, which are defined by the predicate. Okay. Another way to check arguments is sometimes it's also just comes from a need, is to use partial specialization. So, for instance, you have a class or a template class that requires the template argument to be a tuple. Okay, and you want to tell the user that if the user is using something else as a template argument, that okay, this is an invalid argument. In many libraries, this is just done by doing nothing, ending with a semicolon here, and just saying this is not implemented, and then the compiler will spill out some horrible message and saying, okay, I can't find an implementation of this and that, and will I? The new world with sqlpp11 gives us static assert, and we just have to fill out this thing here and say, okay, whenever this is instantiated, I want to get this message, and the compiler will be friendly enough and just print this message to the user. So what can we put in here?
False.
Okay, if we put in false here, that was my first attempt too. If we put in false here, the compiler runs over this code, sees static assert false, end of story. It doesn't even have to instantiate it, because this is always false, so you're gone. Another?
Size of t equals 0.
Const expressions.
Const expressions. Okay.
I think there's something like a false type.
Some
Something
trait
like a false type, yeah.
is
A boolean.
tuple or
A
something
boolean.
from
Yeah.
used.
Sorry?
Is tuple.
Oh. Yeah, you could use that as well. It's also cool. I have a very I found a very short solution for this. Let's go to the next slide. Just this one here. It's a template that takes any kind of template argument and has a value of false. And you might ask, what's the big difference between this thing here and just writing false in there? It's a template, okay? So
Specialized
to give you a hint, what's the difference between this here and that? I mean, if you don't know false type, the standard false type, this basically